Hello and welcome. Today we'll be going over vectorization, also known as array programming. It's a little harder than the stuff we've been doing before, but it's very rewarding to learn. Let's get started. This topic is a little more complex than just using a function like sum or mean or stuff like that. Essentially what it is applying a single operation to an entire set of values. Let's look at an example. So we create two test lists, A and B, run this code, and then we're going to try an example one. So add A and B together, adding each corresponding index together. So here's where we want to go. We have A here, 0 through 8, B here, 8 through 0, they're just flipped, and we want to add each individual index together and create a new array with all the indexes added together. So 0, 8, 8, 1, 7, 8, and so on. Now in normal Python, this is a little annoying to do. So I'll write out the code here. So C1 equals promise, we're just making an empty list, and then we want to iterate through every item or every index, and then make add to C1 A, I, and B, BI. So this is going through the list, both A and B, adding each individual index together. So on the first iteration, I'll add 0 and 8, second 1 and 7, and then add it to the list C1 as it goes through. So when we look at C1, you now see it's all 8s. This works just fine. There's an even better way to do it with NumPy. So make a new array, C2, and then it's as simple as just this, A plus B. And that'll give the exact same answer. You see it's wrapped in an array, but this just signifies that it's a NumPy array, not a normal array. So once this code is doing exactly this, except it is hidden behind the operators. So now let's go down here. We can see C1 produced from the normal Python and C2 produced from the vectorized code, exactly the same. This also works with other operators. So if we wanted to say do A minus B, it works just fine. Or how about A divided by B? That would be not good because B is a 0 in it. So let's just do C1 because there are no zeros in C1, and that's fine. So A, 0 through 8, divided by C1. So 0 divided by 8, 0, 1 divided by 8, 0.125, 4 divided by 8, 0.5, and so on. So it's just doing the individual operation for every single index corresponding to A and C1. It works with multiplication. So like you'd think multiplying two vectors together would be a dot product, which is what matrix multiplication is defined as. But in this case, it's just index multiplication or scalar multiplication, or it multiplies each individual one by the other individual. So 0 times 8 is 0, 1 times 8 8, so on. And then down here we have some timing. The vectorized time is 6.00, 10 to the negative 7 seconds. And then the standard time is 45, 10 to the negative 7. So the vectorized time is roughly 7.6 times faster. And this is only for an 8-value array. As you scale it up, it'll become faster and faster. So now on to example 2. Multiply each value in A, which is the array 0 to 8 by 4. Here's an example of what we want to do. We have the array A, we have the value 4. We're going to multiply every single individual value in A by 4. The way you do this in Python is by making a new array, going for n or number in A, b1.append, and then n times 4. And this will create a new list, b1, that has values of A but multiplied by 4. So you can see here, this matches this. That's simple enough. But the vectorized format is even simpler. So b2 equals A times 4. And that's it. Now this b2 is exactly the same as this. Look at that. Instead of having to deal with the for loop, you're just writing this single code multiplied by 4 for every value inside A. That's the entire premise of vectorization. You're applying one operation to all values inside the array. And again, this is quite significantly faster, between 5 and 6 times faster. Now for a little more complex example. I'm sure you guys have heard of Euclidean distance. but I added a diagram here to help explain it. So essentially, Euclidean distance in 2 dimensions is when you have point 1 and point 2 defined by x2, y2, x1, y1. You want to find the distance between them. The formula is down here. So distance equals the square root of x1 minus x2 squared, y1 minus y2 squared, and then so on for every dimension. So right here we have x1 minus y2 equals the change in x. This blue line equals delta x. This is the Greek signal for delta. Over here we have the red line, which is equal to y1 minus y2, or delta y. And then if you go up here, we can see square root delta x squared plus delta y squared equals distance. And that matches the formula down here. And then here's a quick example without programming. So we have point 0, point 1, point 1 and point 2. We want to say x1 minus x2. So 0 minus 5. That's shown here. And then y1 minus y2. That's 0 minus 5 again. That is negative 5 squared, which turns into 25. Plus negative 5 squared turns into 25 again. And when we add them together, that gets 50. Square root of 50 is 7.07. That's easy enough to do on paper, but what if we want to program it? So the normal Python approach is a little annoying to do. If we were in 2 dimensions, we'd only have 0, 1, 8, 7. But we want to expand this to multiple dimensions. Imagine if like a large data set with a lot of values. We don't want to just do only the first 2 values. We want to focus on all of them. So in order to do it in Python, to work with any length list, we have to start with a summation. Go for I in range length A. And then so we're going from 0 to 1 minus the length of A. Difference equals AI minus BI. So that's the same as this guy in here. So we're doing the subtraction. And then we're moving on to the power. We're doing the difference. Power of 2. Again, we're still in here. And now this is where we add all of the different values together. So run in sum plus equals power. So now we've done each individual value, so x, y, and z. Found the difference, squared them. We've now added them all together. And now the final thing we need to do is square it. And now this, assuming we print out just 1, will give us the answer of 10.95. But now, let's do it vectorized. So you'll see here we have a for loop. We have some operators that are applying to individual elements. If we vectorize it, we can turn all these individual operators into ones that operate on the entire list. So let's go dist2. And then this is a little complex, so let's start with the difference. Difference equals A minus B. This is the same as what we went over above. We're taking every value in A, subtracting it from the corresponding value in B. Now I want to do the power. So power equals diff power of 2. This is, you see how this is mirroring the code up here, except there's no I. It just knows to apply the power of 2 to every single value inside. And now we can use the sum function to find the summation of the list. So mp.sum power. And this will add all the individual powers inside the list together to create a final result. Now the final thing we need to do is calculate the square root. This 2 equals numpy.square root summation. Now down here, you can see that they are the same value. And then if you wanted to, you can combine this 2 into one line. Which will make things a little simpler, but this is definitely the multiple line one's easier to follow. And you'll see the same result. The benefit of using the vectorized one, aside from the fact that the code is simpler to read, it also works in more dimensions. So imagine A and B were more than just 1 by n. Imagine they were, say, 10 by 10. So I'm just generating numbers between 0 and 100, 2 arrays, and then I'm flipping b around so the values of a and b are not equal. So now we have two arrays, a and b. Let's try to run the normal Python one. Crashes because we're only calculating the lists. So this is doing some weird list calculation stuff and it's not actually finding the right value. If we go down to the vectorized code and comment this out and just use the more advanced one, a minus b will work in any dimension. So it's looking at the 0, 0 value in a, subtracting from the 0, 0 value in b, and doing so for all dimensions. That code runs, we get 574. And that's some of the benefits of vectorized code. The notebook is posted in the description. Make sure to check it out. I have two versions, one that you can fill in or one that has already been filled in. I recommend going through the blank one first. It helps you learn better. Thanks for watching. Hope you enjoyed the video. If you did, please hit the like and subscribe button. If you want to get notifications about new videos I release, tap the bell. Any comments or questions, put them below. Don't forget to follow my Instagram account, Programming Pilot, and I'll see you in the next video.